It's the 21st century, and we still putter around with rockets? I was promised warp drive. I see no warp engine. Why? Why? Hi, I'm Dave Dooling, Education Director at the New Mexico Museum of Space History. For the most part, we move through space using HERO's steam engine. About 2,000 years ago, Hero of Alexandria made a metal sphere spin by letting steam spray from two nozzles. Gunpowder rockets were invented almost 1,000 years ago. Dr. Robert Goddard launched the first liquid propellant rocket 95 years ago. And modern rockets have taken humans to the moon and probes past the edge of our solar system. But it takes years or even centuries for light to travel from one star to another, so science fiction writers have invented warp drives, wormholes, and hyperspace jump gates to move us around the galaxy. Each is closer to fantasy than actual science. This is not to say they cannot exist, it just says we have no idea how to make it happen. We are still waiting for the Chicago pile moment. In December 1942, scientists at the University of Chicago built the world's first nuclear reactor. A control rod was edged out of a stack of graphite bricks encasing a uranium core. Detectors confirmed that a chain reaction was splitting uranium and converting a tiny bit of matter into energy. The atomic age was born. So why don't we have warp drive yet? First, a little about how rockets work. Like Hero's steam engine, they are just flying tea kettles. Put cold stuff in, add heat, and hot gas pushes you to the planets. Most of a rocket stores oxygen and fuel. Thrust is produced when the chemicals burn and push their way out of the combustion chamber. Or we can use electricity to heat and then repel a gas. Ion thrusters power Dawn to the asteroids, but a grasshopper has a stronger kick. Former astronaut Franklin Chang Diaz is working on a flying microwave oven. Vasimir, the variable specific impulse magnetoplasma rocket, heats a fluid with radio waves. It might make the trip to Mars in just a few weeks instead of months. In the 1960s, we experimented with NERVA, the nuclear engine for rocket vehicle applications. It was a graphite core reactor cooled by liquid hydrogen, which then became hot rocket exhaust. Variations might be used for Mars missions. Fusion, turning hydrogen into helium and a bit of energy, is far more efficient and powerful, but also more challenging. The Orion project would have used small, rapid-fire nuclear bombs to push a spaceship. So how about antimatter, the stuff that powers Starfleet? Every particle of matter has a corresponding antiparticle. When they meet, they annihilate to become pure energy. No antimatter mines in this corner of the universe, so we'd have to make it in special particle accelerators and then contain it in a magnetic bottle called a penning trap. The matter-antimatter reaction would just heat a fluid to push the rocket. It's still just a flying tea kettle. But faster-than-light drive is more complex than sitting atop a big, powerful rocket. Quite simply, no rocket can get you even close to ludicrous speed. The speed of light, 186,000 miles per second, almost 6 trillion miles per year, is Mother Nature's speed limit because she gave it a weird twist. The faster you go, the harder it is to go faster. Over a century ago, Hendrik Lorentz of the Netherlands calculated that as you speed up, part of your energy is converted into mass, and time slows down compared to the rest of the universe. All the energy in the universe could never push even one electron to the speed of light. As you approach the speed of light, mass skyrockets to infinity, and time crawls to zero. But Mother Nature left an intriguing escape hatch. While mass cannot travel faster than light, space can. It's already happened when the universe was born in what was more of a great inflation of space than a big bang of matter. Could we do that on a small scale? Miguel Alcubierre of the National Autonomous University of Mexico says, maybe. Inspired by Star Trek, he started writing a paper explaining why a warp drive would be impossible. Instead, he found himself wondering, why not? What emerged is a bit more like Frank Herbert's Dune, where mutated humans fold space to travel without moving. Alcubierre proposed that we might be able to shrink space in front of a starship and expand it behind the starship, forming a bubble that carries you from here to there in a short period of time. It would take no small amount of work. Propelling even a tiny starship would involve exotic matter and converting the mass of Jupiter into pure energy. And like a jet's sonic boom, your arrival would be announced with a supernova-like burst of energy. It would be like setting off an H-bomb as your train pulled into town. All this assumes that we can figure out where to get exotic matter and how to fold space. We are still waiting for the Chicago Pile moment. Until then, we're stuck on the Tea Kettle Express. Thanks for watching, and stay tuned for more stories from space.